All right, today we've got 7.4 special right triangles. All right, so we're going to derive and apply relationships in 45, 45, 90 triangles, and we're going to do the same thing in 30, 60, 90 triangles. Okay, so first up is this 45, 45, 90 triangle theorem. So it says if the length of a leg of an isosceles right triangle is L, so we look here, this is isosceles because both of these angles are 45, which means both of these legs are congruent. And if the length of the leg is L, okay, so they're both going to be L, then the length of the hypotenuse is L times the square root of 2. So L times the square root of 2. Okay, which may not seem helpful right now, but if you knew the measure of L, so let's say you knew L was 3, then this would be 3 times the square root of 2. Okay. Another way to look at it, if I look at this notice, it says notice the side of a 45, 45, 90 triangle are always in a ratio of 1 to 1 to the square root of 2. So this side would be the 1, this one is the 1, and this side is the square root of 2. Some textbooks are going to say it's a ratio of x to x because those sides are the same, and then x times the square root of 2. A lot of textbooks or places you see it won't necessarily use the L because people think it's a 1 instead of an L. So you could see it in a lot of different ways, and that's fine. Okay, so let's look at example 1. It says find the exact values, okay, and the decimal approximation. So we're going to need a calculator for the lengths of AC and AB. First things we notice, we need to evaluate the triangle. It is a 45, 45, so it's isosceles. It's also a right triangle, we see that. So these sides are equal. Okay, they're congruent. So AC is congruent to BC, which means AC is equal to 3 centimeters. That answers one of our questions. AB, however, is the hypotenuse. So that goes back to this idea, or the ratio of them. These two sides are equal, so they're both 3. So this other side is going to be 3 times the square root of 2. That is what this tells us. If it's x, x is the ratio, then we're going to take that x and multiply it by the square root of 2. So AB is going to equal 3 times the square root of 2. Okay, and you can put that in your calculator. Oftentimes you're going to hit the 3 button. You have to find that square root button. Okay, then you're going to have to put in a 2. You might have to come out of that so you're not under the square root, close your parentheses, and then hit your equals on your calculator. Okay, and you should get that it's approximately, so I'm going to put an approximate sign in there, 6.9 centimeters. Okay. The other thing for some of your calculators to do this, to go from the exact value to the approximation, you're going to have to know what key to use. Some of them are going to have the fraction to decimal or vice versa button. Some of them are going to have a toggle button. So it's got like 2 arrows that are kind of colored in and they go back and forth. So you're probably going to need one of these buttons on your calculator to go back and forth between the exact value and the approximation, because you do need both. That's what it's telling you, right? You're working on using both of those. Okay, great. Let's go on to example 2. Down here. All right, so example 2, we're going to find exact values and the decimal approximations again. So we're doing both of those, exact values and decimal approximations, for the lengths of the legs of the isosceles triangle. So it's telling me it's isosceles. So I'm going to go ahead and mark my legs for that, of triangle XYZ. All right, so if we think about, well, if these are my legs, then this side could be X, this side could be X, and this side is going to be equal to X times the square root of 2. Well, now that I know that, I can take this information and write an equation, because x times the square root of 2 has to equal 12. So x times the square root of 2 equals 12. And I solve. So I'm going to divide by the square root of 2 on both sides. They cancel on the left. So I have x equals, again, you can do this out by hand. If you want, you can use your calculator. That's fine too. But in my calculator, it's going to give me 4 times the square root of 3 is what that equals. And then I need that decimal approximation. So you've got to figure out how to get your calculator from here to the decimal. And when you do, you should get that it's 8.5 feet. Okay, so we're just rounding to the nearest tenths place. So this side and that side are about 8.5 feet, and this one is 12 foot. All right, I'm going to go ahead and clear that and move on up so we can look at our 30, 60, 90 triangle theorem and example 3 all at the same time. Okay, so in this 30, 60, 90 triangle theorem, we have the length of the shorter leg. So we're talking the shorter leg is x. Okay, so if I am looking, okay, we have a equilateral triangle here, but it is cut. So we're really looking at this triangle here. Okay, and that triangle is a 30, 60, and a 90. So it says if the length of the shorter leg is x, so that's going to be this leg. The length of the longer leg, let me actually go back and just underline that. So the longer leg is x times the square root of 3. So my longer leg is this one. So this is x times the square root of 3. And the length of the hypotenuse is 2x. Okay. So again, it's kind of giving us an abbreviated version here. Notice the side of a 30, 60, 90 triangle, or the side, yes, sides are always in a ratio of 1 to the square root of 3 to 2. So again, we might say x to x times the square root of 3, and then 2x is another way to think about it. So we are for sure understanding how we can get an equation out of these. Okay, we go ahead and give them a variable. So in example 3, we're finding exact values and decimal approximations for x and z. Well, first of all, we need to figure out where each of these sides go. Okay, so 30 is my shortest angle. So across from that, look at that, is my x. Okay, then my other shorter side is opposite of the 60-degree angle. So this one is equal to x times the square root of 3. My hypotenuse is opposite of my right angle, so z is equal to 2 times x. Okay, so of these, the only one that I have enough information on to write an equation is this one. So I can say 12 is equal to x times the square root of 3. That's what I know. Now I can solve. So I'm going to divide by the square root of 3 on both sides. It cancels on the right. And 12 divided by the square root of 3 leaves me 4 times the square root of 3 equals x. Okay, so again, this is the exact value. 4 times the square root of 3 is the exact. We want the approximation. So you can use your calculator for that. And you're going to get 6.9 centimeters. You are going to have to know how to do this on your homework. So since I'm not there today, if you don't know how to do it, ask a friend, check those buttons that I mentioned earlier, Google it, whatever. All right, so we solve for x. Okay, so we're done with this one. Now we need to solve for z. Well, z, I'm going to change my color to kind of track it. Z is equal to 2x. Right, 2 times x. And we solved for x. That's here. So z is equal to 2 times, When we are doing this, we want to use the more exact amount. So it's going to be equal to 2 times 4 times the square root of 3, which 2 times 4 is 8. So this is 8 times the square root of 3. And then we can find out, well, what is the approximation of that? 8 times the square root of 3 is approximately 13.9 centimeters. Okay, but when you're doing this, you always want to take the exact value, so the 4 times the square root of 3, and multiply it, like plug it in, substitute that in for any variable you have, and only find the approximation at the end. Otherwise, your answer is going to be more incorrect or further off than the exact one because you found the approximation twice. All right, let's go on then. On the back side, we have theorem 7.4.3. The area of an equilateral triangle, so you might highlight that. Okay, area of an equilateral triangle is the square root of 3 over 4 times the square of the length of one side. Or in other words, I would highlight the formula there. A equals the square root of 3 over 4 times the side squared. This is for an equilateral triangle. Okay, equilateral only. So in example 4, we have packaging shaped as a regular triangular prism. Regular here, remember, regular means all the sides are equal, all the angles are equal, which means this is an equilateral triangle. All right, so this packaging shaped as a regular or equilateral triangular prism provides excellent protection for shipping large prints. If each side of the prism is 5 inches wide, what is the area of each end cap of the prism? Okay, so we're just talking the end cap. So just the end piece, we want the area of that piece in there. Okay, and that's it. So we know this is 5, 5, and 5 because it's equilateral or regular. So the side equals 5. So all we have to do, since it's asking for the area, and we know it's a equilateral triangle, is use this formula. A, the area, equals the square root of 3 over 4 times the side squared. And we know the side is equal to 5. So what's going to be the square root of 3 over 4 times 5 squared. And so I'm going to just show all this work out here. The square root of 3 over 4 times 25. Nothing here is going to cancel or reduce. So that means our exact value of the area is 25 times the square root of 3 over 4. Because remember, this 25 is a fraction over 1. So we just do the square root of 3 times 25, but we always put our whole number first, and then the number with the radical comes after. And then it's still over 4. Again, we want to know, we can do a decimal approximation, so you can use your calculator, and you can find that the area here is approximately 10.8 inches square. And it's square because it is the area. All right, that is it for today in 7.4. So, simple, not too terrible with these special right triangles, but those are the only two special right triangles. And you will want to memorize those theorems for the 45, 45, 90 and the 30, 60, 90. Okay, you will want to memorize those. Okay, well, I will see you later. Have a great one.